This is Apache Deep Learning 201. So this is using only Apache software projects for doing deep learning and doing, streaming. How do you interface with these different tools? How to do it with all Apache. This is not a Cloudera talk. This is straight Apache. This is how you can use various tools in the Apache Software Foundation to do deep learning. This is focused on data engineers. I won't go into the background of how these algorithms work or why you should choose one or another. This is for people who come from a data engineering background and want to know, how can I make these algorithms available, in a production environment? How do I get data to them? How do I move them around? And some examples how to use them. If you're already a data scientist, it's going to be trivial, easy, other than the parts with, how can I drop this in a real-time streaming pipeline? How can I use this as part of data ingest? Those sort of things. This is me. If you didn't like this, you can see it again later somewhere else. So this is what my talk's about and who it's for. So if you're not in one of these three groups, you may be bored. I don't think there's any snacks now, so there's nothing to leave for otherwise. But if you've got a little experience doing any of the big data engineering tasks, maybe some Python, some SQL, this is good. My cat likes it too, and he wears a tie. Also for AI, AI wants to know this, and will probably write this itself by the time we do the next talk. So this is kind of a general idea. If you've been around this whole Dataworks Summit, I've shown variations of this. In other talks, I had CDSW as part of it. This is no Cloudera projects. This is pure Apache. Everything's Apache the entire way through. So you start off with Apache NiFi, MiniFi project. For any edge devices, I can run, if I'm using MiniFi C++, I could run TensorFlow, which is Apache licensed but not Apache project. So I'm using Python to interface with MXNet on devices. And they make this very easy now. You could do a standard pip install, and you have a full MXNet. You don't have to do anything else. It'll install the prerequisites of NumPy and all those other Python libraries you want. So the MXNet has become, I'd say, on par with TensorFlow on the ease of install, multi-platform support. It's got everything you need. And according to some of the engineers working on this, who I've met from Amazon, their performance parity with TensorFlow, in some cases more performant. And we now have Keras support. So if you're writing something and you have Keras, you could compile that to MXNet now, see which one's faster. I mean, I don't think anyone has support from either company for those libraries anyway. Why don't you use the one that runs faster? As you can see, there's a lot of other Apache projects in here for different things that you can do. The first part, and if you were here at any of our meetups, talks, demo paloozas, this is kind of a common feature. I like Apache NiFi. It's kind of the Swiss Army knife for everything, for moving things around, scheduling things. So I don't need cron anymore. I don't need to use a whole batch of different tools. I use a little Uzi over there, Airflow somewhere else, a little cron. I could schedule everything with NiFi on any platform, as many nodes wide as I need to. We've scaled it up to 500 nodes on Kubernetes and Google Cloud, supported up to 12 petabytes of throughput. So it'll scale out as big as you want, and that's in the full 100% open source Apache project. And it gives you a lot of features which are helpful when you're doing things like exploring data, and while you're exploring data, running those algorithms at the edge or in stream or in the cloud or wherever else you want to run them. Things like back pressure are important when you're not sure how long these algorithms might take to run. Sometimes on my laptop, there could be a lag, and it might take 15 seconds, a minute to run one of these pre-trained algorithms. With NiFi, it's buffering, so I don't get to the point where I can't run things because of a slow process. This is nice also, and I could start looking at the metrics around that to say, okay, this algorithm is slow. Should I run it on multiple machines now, or do I need to send this back to the data scientist to say, hey, this is slow. Is there a reason it's slow? Does it need to be slow? Is there a way you can rewrite this? You know, maybe we try and push it to a different algorithm. Can we push it? You did Keras. We could push it to TensorFlow, or we could push it to MXNet, see which one's better. It's a very useful thing. So what we do is we have to get data. We have to get images. If you're doing deep learning, you're probably doing it on images. You might be doing it on text. You could be doing it on time series for sensor data. I have a number of people doing that in the energy space. So you got to get this data. Easiest way to do that is with those two Apache projects. They're agnostic on what the data looks like, where it comes from, but they give you one standardized open source way to get all that data, do routing, that basic first part, which can often be tough because a lot of systems out there are very specific on, okay, you can only grab XML, but only if it matches this schema, or I can only grab JSON if it has this many fields, or it's got to be a known schema. It doesn't matter with NiFi. And then in the middle, move it around with NiFi, but there's a lot of other projects depending on what you need to do with it. Now, you might need to just store it, and that could be an HBase, Druid if you were here before, Phoenix, Hive, Impala, Kudu, HDFS. There's a ton of places to put it. If you're trying to write this in something other than NiFi, each one of those things is a project. You're writing it, you deploy it, test it. Eventually, you have an output source. With NiFi, I drag and drop all those boxes at once. I could save to all those things from the same data source and do it in less than an hour. How do we gain insights on this data? There's a lot of open source projects that are very strong that sometimes get overlooked. OpenNLP will do a lot of nice things for you. I have written processors in NiFi that do some of this automatically. I'm not doing the full NLP thing there, but I've got sentiment analysis. I've got pulling out names, locations, addresses. So NiFi is really good for grabbing text, even if it's out of a PDF. Even if it's out of an email that has zipped PDFs in it, I could pull those out of the zip individually, decompose it into text using Tika, grab each line and send it through NLP to identify names, addresses, locations, weights, measures, currency. Pull those apart, and you could start doing some, as you can imagine, I could send that to a more intelligent NLP model to do more. And the next part is I have this data. I have some data that maybe has GPS. I can enrich it, or if I have IP address, I can enrich that with the geolocation around it. I could add weather information. I could pull data out of existing corporate systems. So now I'm taking sensors, machine learning at the edge, all this data, combine it with Hadoop or Oracle data that you have already, then run some different machine learning. And with MXNet, Tika, and NLP, you could do almost all that completely open source. And there's a ton of example code and pre-trained models in the model zoo out there for you to play with. I personally like MXNet. Ooh, let's move this. Sorry about that link there. We change them on the fly. So why is MXNet cool? I mean, there's a lot of big companies behind it. As you see there, that's a pretty good list of people who know about running machine learning and deep learning. And if you look, it's cloud first, which is something that's really helpful once you start running these algorithms and you want to be able to spin them up. It supports a lot of languages. They just added Java support, so I wrote a NiFi processor. It's pretty good. It's an experimental API. It's not fully productionalized yet. It's based on the Scala API. It's coming along. If you look, the team behind it, if you've done any machine learning, XGBoost should be extremely familiar. So it's got some of the same design patterns, same smart thinking behind it. Runs very easily on Yarn, Spark, on a regular Python node. Runs on pretty much any device I've found, including some off-priced ones from China. It's a pretty good option there. The price is good. The scalability is great. And as you see here, there's a full model zoo. So if you want to use pre-trained models, they're very easy to do. That's as hard as the install is. The other couple of pip installs there are for extra libraries. If you want to support Keras, that's an extra pip install. GlueNLP is an extra set of models and API to make doing NLP easier. And GluonCV is my personal favorite. It's a whole bunch of computer vision pre-trained models and very easy to use API. If you like Keras, Gluon is even simpler. It makes it very easy to be able to do your own computer vision or use the ones they have, which are very rich. Also, it supports NVIDIA for their CUDA optimization and the math kernel library if you're using Intel. So it's very performant. The updates keep coming. What's nice is if you've heard of Onyx before, Onyx is supported by MXNet, Apple, Microsoft, a couple of different deep learning libraries. So we could export directly to Onyx, and now you've got a neural network that you could run in different places. Obviously, also with Keras, you can run it in multiple places. So if you don't, say you don't want to do Apache MXNet, you could export it and run it on a different system. And these are some examples. If you haven't looked at deep learning computer vision models, this looks like, I don't know, a nonsense directory. But if you have, I mean, it's all the ones you could think of that are out there. Someone has ported them over. It's all the major ones that have come out in the recent papers. And they all run as fast or faster than the other implementations. I have example articles on how to do this in different environments, including on native Hadoop, on Hadoop with Spark, on top of Yarn, on top of a Zeppelin notebook. I've done it, if you were here in the previous talk, I did it in CDSW. It runs on any environment. YOLO is a very popular, you'll look only once. It's a popular computer vision library that works pretty well with MXNet, and that comes out of the box. If you install GluonCV, it's literally 3 lines of Python code to use it. You point it at your image. To retrain is only a couple of lines. Obviously, you get your data. It's got pre-trained for the common YOLO things, which is people, things in a room. So it's really good for a conference because it picks up, drinks and people and computers, things you'll see. So that's kind of nice. Another one, similar variant is the faster RCNN. Again, similar, trained on different data, gives you the same kind of results, runs pretty fast. This one I like because it highlights the what you have. I'm looking at a street camera here, so it's obviously picking up a lot of cars and vehicles. Again, that's the actual code up there, that line, net equals model zoo. That's the whole Python code you need to load that model, and then it's just another call to execute it, and you apply your image. Similar, they have one for Deep Lab 3, which, saturates out the colors, but completely uniquely identifies them. So the next step you could do in this is mark what's in there. Again, this has been trained on cityscapes. So if you're doing, say you're looking at a city and you want to pick out individual buildings, it could isolate them in the image and then you can name them later. Again, this one's pretty intensive. This is kind of specific purposes. Another one, like I said, there's a lot of these algorithms that have just come out. These are already available and they're already running in a fast method, pretty easy to do. This one just came out like a week or so ago, so it's not in the final release. You got to use a pre-build on this. And this is if you've seen the simple pose estimation. You could do it on a video, and you could see where the joints move. This is really good for figuring out movement. Probably more interesting for medical companies are looking at various movements or accidents, see what's going on. To me, I just think it's cool. You could see how things are moving. It's better when you see the person running. Another thing that's really cool with Apache MXNet, you might not be able to get a commercial model tool. If you're in my other talk, I was talking how you could do automatic model deployment as a REST API with CDSW. If you don't want to be in a production environment, you want to be 100% Apache and run on your desktop. MXNet has an open source model server. You point it at your model with a couple parameters, and it spins up a REST API for you, one that's pretty easy to integrate with NiFi or curl or whatever. As you see here, the result of posting to it, you get pretty easy to parse JSON that gives you what the prediction is, probabilities, classes, pretty similar to what you get anywhere else. As opposed to TensorFlows, it's not returning protobuf or something that's a little difficult to interface with. It's standard JSON, which is kind of nice. I've also wrote a native Java processor for MXNet. This is based on their Java example code for doing single-shot detection. I put this out there as an example for people who are interested in exploring doing native NiFi processors with MXNet. They're expanding that API. I'm guessing in about a year, it'll be pretty full, and we'll have the whole model zoo in there. And then I'll add some more examples. But single-shot detector is pretty nice. And when I'm running it in native Java, I'll show you an example. It runs really fast. And since it's on NiFi, I could automatically distribute that to 3, 7, 50, 500 node NiFi cluster. And now I'm doing that distributed inference, very simple. So that's kind of nice. As that API increments, we'll see more stuff coming out of that. I mentioned slightly before MiniFi. The reason why this is important is because a lot of times you'll have a smart camera or you'll have a small device. Like if you were at the Demopalooza, I had one with a Movidius and with a Google Coral. With a device like this, with MiniFi, you can control what's going on there and run deep learning on those, on like a camera or any kind of edge data as it's coming in. Now, obviously, I'm not going to do training on these low-end, low-power devices because you just don't have the horsepower. But for doing something like classification, it could be sub-second. Again, MXNet installs on any of these edge devices and works with MiniFi quite well. And I've done a couple examples of this. This is the source code and the articles. So if you're interested in trying this hands-on, go to the site. I'll publish all these slides. You can go there, download the code, try it out, and play with it. It's very easy to install. It'll install on a very simple laptop or even a small Raspberry Pi. What's nice is one device expands easily to multiple devices. And if you're in the other talks, it's very easy to distribute your model out there and run it and pull back things like GPS data, other data, and apply that at the same time you're doing your deep learning classifications. And this was some articles on doing that on with the Intel Movidius, which speeds up these algorithms a little bit. This is one of my more recent examples. Here is I have the Movidius, and if you were in Andy's talk, I've got the Inky P hat, which is a e-paper display. What's nice thing when you're doing thing on a device to see what's going on. It's nice we get the full data provenance as it comes through the system, but it's good to have some kind of immediate notification. What are you doing? What's your IP? Those sort of things. Now, to go to the other side of the spectrum, we talk small, now we talk big. On your latest open source Apache Hadoop platform, we now have full GPU support. And we did this purposely so you can run deep learning workloads in a yarn queue, so you could segment who has access, who gets how much permissions, everything that you knew before, all the security and governance is in your platform, and can be distributed as many nodes as you want. It has GPU affinity, so you say run this only on the nodes that have GPU, give me at least 6 of them. That could be specified in the when you're running on Hadoop. And there's a couple different ways to do it, and it's pretty straightforward. This is an example for running it without using any Spark. We don't have to use Spark to run MXNet. We can. But in this example, we're running it straight through Hadoop. That is the full code to do it. There will be a UI at some point. But right now, it's you run this yarn job. You drop in your MXNet Python script. It runs it. I'm specifying the RAM and the number of cores. I could also specify number of GPUs. And then whatever my yarn queue permissions are will let me scale up to there depending on what's available. It shows up in the standard yarn interface, and you see the jobs running. And when you're done, you can see it. I have a full article in the example code there. Something that came out recently, which is pretty awesome, which I'm talking about in DC Monday. One of our developers, Wang Datan, has developed this project Submarine, which is now a separate sub-project from Hadoop Yarn. This is a very smart, very easy to use workload for deep learning, and it lets you scale this up, run it very easily. One thing that's really nice is you could spin up a tensor board, which works with MXNet as well, or Zeppelin, or your deep learning job, specify it, and it runs smart, and it's a little more powerful than the standard way. This is a couple of different existing projects that were running deep learning on Yarn contributed to this. So this will be the official one for anyone interested in running these workloads on Yarn. That's all the slides. I'll start showing you some code because we try to run it live. So what I'm doing here is I'm pulling in a bunch of different URLs that are showing weather haze patterns in different parts of the US. And then here I'm running, this is that custom MXNet processor that's doing single shot detection. And we can look and see how that goes through the system. This is all the configuration I need. I just point to that model, which is pretty straightforward. And then we can look, we could see which ones have run already, which is one of the nice features of Apache NiFi. I'm going to show you what's happening here. It's showing you everything, all the metadata about this run. This was the image. That's the unique file name. And here is start of the data that we got back from doing our single shot detection. If you looked here, I didn't know a good way to return this data. Maybe I should do an array of JSON. I'm not sure. But right now I'm returning all the heights and widths and X, Y, so you could draw the images around on this image when you get it back. So you get those heights and you get the labels. So you put all the ones together and you could draw a line around a potted plant there. You could draw one around a chair, and it's got all that plus the probability, which is really low. So one thing that we could do with NiFi, if we get a probability below a certain threshold, we could just say this is garbage data, throw it away, or send this to something to say, hey, you got to look at the training, maybe send an alert to someone to say, hey, you're trying to do this on something and it's low probability. One thing you're going to want to do with any kind of application is train it against just your set of images. That'll improve performance, improve everything. And it's really easy to retrain these models against a small set of images. I've got an electric company that's only trained it on a couple of different solar panels. So it's solar panels in different seasons, solar panels where there's damage, where there's heat, when they know they're off, and then they could quickly compare those, and they'll get really high probabilities because it's a small set and they know what they look like. You can also do it, train it on people, everyone in your organization, so you know when, oh, he's not sitting at his desk, and it's Joe, what you doing, Joe? Those kind of things. Again, like I said, the width, X, min, max, you could draw your little box there. But it's pretty straightforward to do that. And one thing I'm doing with those results is I'm pushing them to Slack. So I get a lot of information in Slack. Guess I've been running this a while. And you see the results in there. There's the image that we found. Those results. I could mark up the boxes on here as well. But, you know, it kind of blocks out the image when you put 5 of them on these small images. But you get the idea what it thinks it's in the image. You know, what's the probability. What's nice is we're able to push this to any place you want. So you could take this data and you could programmatically do something based on it. So say I have one customer who has, they have a big brown truck full of packages, and they've trained it on different size of packages and also determining labels. So we can grab, you know, those barcode labels or any of those kind of labels are very easy to discern with deep learning. So first we get all the boxes in the truck. You know, we know 2 are supposed to leave. This picture, there's only 1 left. We missed 1. What happened to that? Or take a look at the box, scan the image on there. It's got a barcode. We scan the barcode, get the information. Doesn't match up. And we could do this as part of a flow. And I could do this with MiniFi in that truck. So MiniFi is sitting in the truck on the roof of the inside of the truck with a little LTE to send the thing out and a couple of cameras. Takes the pictures every minute, analyzes them. If anything looks wrong, makes a phone call out. Sends that data. They could do processing. Otherwise, it waits for once an hour to save cost on making those calls. And MiniFi lets you aggregate that data and wait to send it in a batch. In case again, if you have low power or low energy issues, you don't want to constantly be making network calls out. Too expensive. This is the article I have on this flow. So if you're interested, you could really dive down. It's got all the source code of the Python, all the source code of the NiFi. It's very easy to follow along, and you could do it yourself. And you could start training it against your own data. It's very simple to do. So this is still running. And as you can see, this is running on my laptop, which is running the presentation, running a bunch of other things. And it's taken a couple of seconds to run each one. What's nice with NiFi is I can look and see which ones ran, what the content looked like. There was the image. Obviously, it's raining there. Where is it raining? Which traffic? Brigadine. Brigadine is a seaside town in New Jersey, about 10 miles from where I live. So I guess when I get home, it's going to be raining. Good to know. You know, we could analyze that, see if I'm training against weather images, I could look for certain weather conditions, match that up against regional weather reports and see who's more accurate, or to see, should I bring an umbrella today or not? You know, fun use case. So what's easy about this is with NiFi, I can call the Python interface because there's some more models in the Python one that aren't there yet. It's slower, but it does give me a different interface to getting to deep learning models. And a lot of people like working in Python. We have a couple different ways to interface with Python. The easiest way is I could just call it directly. And then when I'm done, I get my results of that. We look here. I put it in an attribute. You know, we got, let's see the results of our YOLO. We could find it down here. And then once we have the results, I parse it, store it in a thing. I can run queries on it. What's nice about that is, if we had a query, being able to run queries on the results of live checking of cameras via open source deep learning, computer vision is pretty cool. So now I have a SQL interface against the results of deep learning models that can run pretty much anywhere we mentioned. If you want to connect it to Yarn, I can call a Yarn job directly. I can interface via CDSW if I'm going outside of open source. I could use Apache Livy to call them out, or I could call Yarn directly. Or, like I said, I could just call a Python script if I want to use the Python libraries. And that is one example of doing that. Now, in the previous talks, I asked people, what were you more interested in? Are you more interested in seeing more of the deep learning? Are you more interested in seeing some of the NiFi or how we bring this up? We have a little time, and since it's the last talk, I don't think people are going to, chase this out. So if people have specific questions, I have time now to answer them. Otherwise, I'll just go through some extra demos and maybe dive into the code. Is there something that's more interesting than something else? Sure.
Okay, so you said in one of the slides that we can run MXNet on Spark.
Yes.
And you mean the new feature in Spark, which is the barrier execution mode? That's what you mean?
Which one do I have? Let's see. There's a couple different ways, but there is an MXNet on Spark library. Let me find the slide for that. Yeah, you can run it on Spark a couple different ways. Where is it? Also, an unknown feature if you're running Spark on Hadoop. If you pass any Python to the Spark API, it will run. It won't run distributed, so that's an issue. It would run in a single node. To get distributed, you'd have to use the MXNet on Spark library. So, I mean, it depends on how you want to execute it. I think you don't really need Spark for this. I mean, I like to keep the deep learning separate from Spark to keep them isolated. What's nice about this is if I run it directly in Yarn, which you could do the same on Kubernetes, you don't have that extra runtime of having Spark, and it's still distributed. We have ability to access shared data through HDFS. And typically with deep learning, we don't have shared memory. So, I mean, the value of Spark isn't as rich to most deep learning use cases. I'd be curious if someone had one. I know some of the Spark people are doing it. I'm not sure what the advantage is. I mean, other than if you have a Spark cluster already, you might as well use it. I have a Yarn cluster. It probably makes sense to run it like some of the other tools are doing it, run it directly on Kubernetes. That way you keep it isolated and you can use the latest versions of the libraries as they come out. Because if you have to try to update all the versions of Python and all the related libraries, any of these deep learning frameworks use Keras, and they have NumPy and SIG. The amount of libraries they install is huge. It'd be nice to keep that isolated in a Docker container and not pollute your Spark or Yarn space. And with Submarine, we can run Docker containers directly. So I can push this workload inside a Docker container and spread it on my Yarn cluster. You don't need any other libraries. You don't need to have Spark to interface with that. You can run it distributed, come back, store everything in HDFS, which you don't have to worry about file contentions or which node did I store something on. It's a nice taking advantage of that Hadoop ecosystem and infrastructure that's already there, and you already have a distributed file system. If you're running it in the cloud, you could easily just push that to S3. Same idea, whether it's on-prem or in the cloud, you could still run the same workloads. We have someone else?
From a deployment and lifecycle management perspective,
Yeah.
one of your colleagues recommended to keep the model in a container separate and make a REST call to it. So is that a better architecture, or to run it embedded?
Well, I actually did that talk saying that. Well, if you're using CDSW or you have something that's an enterprise way to have a REST API, and you have that model pre-trained, yeah, it's nice to put that out there and make the REST call. That option in here is the Apache MXNet model server, if we're sticking strictly Apache. If we're sticking outside of Apache, Cloudera Data Science Workbench will do it, and some other tools. And that's a nice way to keep them isolated. But you have options. It's really what makes sense for you to run this. I like having it, like you said, if it's a production corporate enterprise, let's run it in the environment where I have Knox and a firewall and Kerberos and all the security I have. But if I'm running it in Yarn, see the difference is when he's saying run it in Docker and run a REST API, that's classification. I'm kind of jumping back and forth, and I don't think I mentioned that. If I'm running in Yarn, I'm not running classification there. That's just silly. I mean, classification on my laptop takes a few seconds. Training, I want to run it on Yarn or on Kubernetes on something big because I want to be able to do this fast. Because if anyone's tried to use any of the bigger deep learning models out there and train them themselves, if you don't have a lot of nodes or a lot of GPUs or a lot of CPUs, it could take days. There was one from TensorFlow that I still haven't been able to run yet because I had it running for 3 days and I got 5% in. There's just some of them are intense. And, you know, when you're doing the classification, when it's in a REST API, it better be a second or less. You're not training anything in a second or less, even if you're Google. You know, it's just, they require a lot of math, and that takes a lot of processing. So, yeah, run wherever you want to run classification. I can run it on a Raspberry Pi, on the laptop, in process, in a node, wherever. If you're training, you better train it on something serious. And that could be Yarn, that could be Kubernetes in a big cloud, could be on a big Spark cluster. If you have a big Spark infrastructure set up already, and you've got all your permissions there, all your users there, run your MXNet there too. That makes sense. But if you don't have that, whatever one makes sense, they all work well. These are all, you know, tested for a number of years. If you saw the people behind this, these are people who are running in production. You're talking Microsoft, Apple, Amazon. They're the ones pushing it. When you see those models that go onto your phone, those are translated from MXNet. If you've got a lot of them, you could run them in Yarn, especially if you got a big cluster. Or you could get I mean, how many's a lot? Are you doing them in batch? Is it like millions of them?
5 million.
That's a lot. Are they big images?
Yeah, the bigger the better, you know.
Yeah. Well, that is a problem with some of the models have to be retrained. A lot of them will take your image and shrink it down to like 200 or 300 pixels. So why'd you give me that big image to start with? If you don't train if you're using a pre-trained model, they're not looking at your, you know, 20 meg thing. They shrink it down. That's why I use a PS3i camera, because it's 300 by 200 usually. So if you didn't pre-train these models, like if you're looking at an X-ray or something or a big fancy picture, the library has to shrink that image down before it runs the classification. Oh, if you trained with the big images, that's fine.
But if you want to use VGG16, for example, it's a small image.
Those are small. Most of them are trained on small ones, yeah.
So in your opinion, imagine that we have gone through that issue of the size of the image.
Sure.
How's the best way to speed up classification? It's the same way with training, right?
Yeah. I mean, use a bigger cluster, put something in front of it. They just came out. I don't have it with me right now, but there's TPU accelerators and there's GPU accelerators that'll speed that up. Like, it's not the massive increase you get with training, but with the Google Coral TPU, which is a USB, you can plug into any Ubuntu system, it'll speed up TensorFlow Lite models. I think it's like 40 to 50% increase. From the Raspberry Pi, I noticed it went from 3 to 4 seconds down to sub-second. So that might be worthwhile. They're pretty cheap. And they also are just releasing a board you could put in there, and Intel has something similar, and so does NVIDIA. So it might make sense to get a TPU that's kind of trained to do just tensors.
So you would not use a GPU in this case?
You can, but they're expensive. I mean, you could get a low-end GPU, because if you buy a big one, you know, how many things can you parallelize on that one machine. If you get small devices, you know, you can map them to a lot of different virtual, to like Docker containers, split them up, because you probably don't need that many cores to do that. I'm just thinking cheaper. I don't know. You know, you just buy 12 DGX2s, right? For, what are they, 2 million each? Get a couple of those. Or find these. I was told that the Google GPU instances are like on a back order. The same with Amazon. If you try to get them and you haven't pre-allocated them, you might be searching for them. It's pretty hard. I think for classification, just get more cheap nodes. And get it to TPUs. They're 50, 80 bucks. That'll speed up the classification. But if you got a Hadoop cluster already, spin them up for classification. I think the only thing I'd worry about there is there's some yarn spin up time. There's checking the queues. And then it's coming back. The other option is you could spin up NiFi and have that host the REST API calls. And that might be able to do it faster. I mean, because I could spin that up on Kubernetes really quickly, spin it down when you're done. I don't know. There's a couple things to try. You could try the MXNet model server. Like you could convert your model to, if it's in Keras, you can convert it to MXNet, or you convert it to Onyx. And then you can run it directly with the model server. And then that'll let you do multi-threaded. And you could run that on a couple of small nodes. That might be fast enough. Just got to copy your model class to it. You know, that might work.
Thank you.
We got a little time. Anyone else? Okay, I think we have, are we close to the official time? I think we're close to the official time.
You can show some of the cool NiFi code if you like.
The which one? NiFi queue?
Code, yeah.
We'll just browse the queue. Let's see what junk is in my queue. Yeah, this is a nice feature with NiFi. Oh, there's a lot of stuff in that queue. Now, the one thing I like with NiFi is these are configurable queues between every process. So say you do something dumb like you break something, you don't lose your data, which is kind of important. Like this is a reason why this might be good for your classification. You know, if something's too slow, it'll just back up, and then I can go, okay, I need more of whatever I'm running. And I could just go, okay, add another NiFi node, and once that NiFi node is added to the cluster, that'll help process more. And you go, okay, it's still too slow. You know, okay, let me keep adding more. And these queues are configurable, so I can set how many objects I'll hold, how big it should be. How do I load balance it between nodes? And what's nice is this is dynamic. So if I add another node, especially in the Kubernetes edition, because it's very easy to add a node in Kubernetes, the more nodes I add, they'll instantly be added to process the flow. There's no starting or stopping anything. There's no, okay, let me register something and then wait till everything's done processing. While I'm processing, add another node. It'll just be something to process from this queue. So that'll be nice. This will distribute it, and you can decide how you want to distribute the load, how big this queue is between them, and that's between every step. That's not like from just the start of the process. Between every connection, everything you do, this is configurable. And this holds not just the data, all the metadata, which is kind of unique. So, you know, say you're using this classification and you're renting this out to someone. You know, if you want to use our classifier, we charge you, you know, X per each 1,000 you do, or the number of bytes, or however you want to specify that. We keep a full trail of what we call data provenance, and that's every bit of metadata about your packet, how big it is, when you got it, and a unique identifier. So someone goes back and says, I didn't make those calls. Well, I got your IP, the date, the size of the call, this was the HTTP result, and I have that in a full queryable log that I could just run a report ago and go, this is your bill for the month. And, you know, this was used at the NSA for a decade before it became open source. So it's pretty stable, and it's been used for some interesting use cases. So it's got all those features you need for doing something like, we have some commercial data marketplaces where people are using NiFi. That's this trucking company, Tremble. They combine their blockchain and then feed it into NiFi so that they could monetize data out to their partners. So they get some people will provide data in exchange they get a aggregated amount of data back. So say you're a small company and you do a little bit of something, like for the trucking, I have just my trucking routes. What they do is they take everybody's trucking routes, all the information on which routes were fast, what was the weather, what was traffic conditions, are these good roads or not? And they pull all that data in, run their own analytics and machine learning on that, and then provide a feed out to people for a price. And they can monetize that because they know who took how much when, and that's all done through NiFi. And NiFi can keep all those records for you, and you could create billing records right from that and send them an email with their bill. Here's your money. Give us money. It's kind of nice, all open source. Very configurable. Everything you see on the screen is actually a REST call. NiFi is just a very slim JavaScript app that makes a lot of REST calls. So if you open your browser and put on the JavaScript console, you'll see thousands of REST calls. Everything is fully documented with Swagger REST API. All this is automated via REST. We also have a command line tool to do it. And one of my colleagues, Dan, wrote a Python wrapper. So you could write all of this and operate all of NiFi with Python if you don't like fancy GUIs. I kind of like a GUI.
What's the name of this wrapper?
It's really hard to pronounce. It's NiFi, but there's some extra letters in there. If you look for NiFi Python API, and if you see a guy named Dan next to it, that's the right one. Let's see if I can guess it on the NiFi Pi. Let's see if we get it up right away. Yep, this is it. And what's cool is since it's Python, I've executed this inside a Zeppelin to call NiFi. What's cool is it does more than call it for doing metrics. I don't know why Dan doesn't do a talk on this one. It does like smart things like if you want to do DevOps and push from one system to another, fully scriptable. If you want to build a flow from scratch, run it, grab the data, and then shut it down, delete everything, you could do that in a couple lines of Python. And it'll pull existing flows out of registry, put ones in the registry. It can basically do everything you see from the screen in a Python fashion. And since you can watch those calls, you could do what you want in the GUI, pull those calls out, use the Python and turn it into a Python script and never use the UI. That's up to you. If you're coder first, it kind of makes sense. He's got a lot of helper ones in there for doing things like deleting a whole group of things, stopping things, starting things. What's nice with NiFi is while you're running, you could stop any piece of a flow and everything else keeps running. So you could stop something around something, delete the processor, programmatically put a new one in, and then start it without losing any data. So if you want to change things while they're running, you could do that and do it programmatically. This was a big use case for the NSA. Most enterprises don't want you changing production, real time while it's running. I know there's some internet companies who do that, but I don't think most of you can go back to your company and go, I'm going to stop production while it's running and change code. If you could do that, tell me about it. That'd be pretty awesome to hear, but I don't think that's the case. This is a pretty cool way to do it because you just put in a couple of pieces of data and you could spin up a lot of things. You could do a lot of DevOps. It's a nice API. But again, it's just a wrapper around the REST API. If you have a language of choice you like, and you can make a REST call, which that's every language, you could just do this in your own DevOps tool, Puppet, Chef, Go, whatever, and just wrap the REST API. And there's a full Swagger documentation, so it's easy to test and do that. There's automatic monitoring capabilities with a couple of third-party connectors. The main one, if you like to use things that cost money, is Datadog. There's a direct connector there. But if you see this, we have one that automatically reports to Embari. And if you look down here, there's all these other ones. These reporting tasks are all configurable. So if you want to write your own reporting system or just push this to a dashboard, you can grab everything you see. That's every bit of provenance, every bit of data that comes through the system, every metric of every node in there. It's as deep as you want. We don't have a pre-built dashboard yet. People keep asking for it, but they keep asking for different things. So we opened up every single API, and they're all programmable. And you could even use those and feed them into another NiFi and have NiFi do all this for you. But if you like dashboards, you know, just output this data to a dashboard. You know, it also produces full, very standard logs that you could pull into any, you know, Banana or any of those fun log viewing tools. There's also, if you have the Hortonworks distribution, there's something called Log Search, which has a nice dashboard for searching and displaying logs and log entries. I've written a small Spring app to show a couple of metrics on a screen, just to show people how to do it. This was used by one of my clients. There's also a really good article by Abdelkrim from Paris, who wrote how to do monitor-driven development. Something to think about that's a little different with NiFi, because the way we develop is to think monitoring first. How am I going to know what's going to happen? And you could write your flows in such a way that they become highly monitorable and not just passive monitoring. I think people thinking passive monitoring is probably that's too late. If I'm doing real time and you want to look at a dashboard and see what happens, well, then what do? I saw something on a screen. Let me dive into it, figure out what I'm going to do. With NiFi, I could be proactive. Whatever condition you want to see in a dashboard, I could programmatically handle in NiFi and make that generic. So if it's, oh, what if we're at a disk space? I can check for that in code and handle that. What if something's outside of a range? What if there's an error? All those are flow conditions. So I don't have to wait for a report. Like every single step gives you the option. What happens if it fails? What happens if it's out of memory? And I can check. You saw all those metadata. It's to look at metadata for any single action at any single time is this process. And I just add something like if error. And then I can examine any single variable that comes through the data or comes from metadata. And we have a full expression language to do some basic programming on that. If you've seen Spring's Spell, it's similar. It's a nice little scripting language to examine those attributes or even content and figure out what you want to do next. So, I mean, don't think of monitoring, think of proactive monitoring. I like the idea of the monitor-driven development. So you're thinking, how do I handle problems? And not just wait for someone to see a report a week later. That's nice. We're probably out of time because I think we're done at 5:30 and the conference is over. If you're able to come to DC, I'll be speaking there too. It's a pretty good conference. It's the first time we've done it on the East Coast of the US. It's usually a little bigger than the European version. And you'll see different speakers. There will be different companies there doing different examples. If you came to the breakfasts and the special lunches, there's other people to see in the community, other people to collaborate with. We get a lot of big companies from the US come out to that. Might be interesting to do it. There may be a discount for people who attend this one, I don't know.